Hello and welcome to the Cisco support community. Today we present a live Ask the Expert event inside Cisco Live and Networkers Virtual. During our event today, our expert will be answering your questions on Fibre channel over Ethernet. My name is Daniel Gerson and I am the Content Manager for Cisco Live and Networkers Virtual here at Cisco. Our expert joining me today is Ozden Karakok, a technical leader in data center engineering at Cisco. Welcome, Ozden.
Thank you, Daniel.
Now I'd like to briefly outline the format for today's Ask the Expert event. Ozden will start with a short presentation on Fibre channel over Ethernet configurations for the first 25 minutes of the program, and then we will dive into the live question submission for the remainder of the event. During our live presentation, you may submit a question to be answered by Ozden and a team of Cisco technical experts using the Submit button on the left side of your console. Simply type your question and press Submit. To see the latest questions and answers during today's presentation, be sure to click the refresh button just underneath the slides. You can scroll up to see previous answers in the Q&A box. The team of technical experts is well versed in Fibre channel over Ethernet, so please begin posting your questions now to give us the best chance of answering them. We'll be asking polling questions during this webcast, and we encourage you to participate by answering them. Just by participating in the polling questions, you will be eligible to win a one-year Premier Pass to Cisco Live and Networkers Virtual, which will give you full access to hundreds of PBS and on-demand webcasts. Now, let's get started with today's event. We'll kick things off with a polling question. How open are you to adopting new protocols and technology architectures used by your organization in data centers? Very open to change, moderately open, neutral, hesitant, or you don't know right now? Please take a moment to answer. Okay, let's have a look at the results. Very good. Looks like most of you are open to change. Now I'll hand the mic over to Ozden, and so she can begin her presentation today.
Thank you, Daniel. We all have different backgrounds. Some of you have Fibre channel backgrounds or Ethernet backgrounds. We're going to spend some time getting everybody on the same page. Here's the agenda for today. We would like to give you a basic understanding of the Fibre channel over Ethernet protocol. We will be discussing where we are with the latest standards. Then on top of that, we will be building single-hop, multi-hop FCoE topologies. So, session objectives. I guess it's obvious why we are here. We are here because we want to understand design requirements of unified fabric. We want you to be able to design single-hop and multi-hop unified networks available today, which meet the demands of both SAN and LAN networks. So, the layered approach is the basic foundation of the data center design that seeks to improve scalability, performance, flexibility, resiliency, and maintenance. We have core, aggregation, and access layers. In other terms, we have tier 1, tier 2, so each layer presents one tier. With the new changes in the data centers, we have increased compute power. We need to save on power and cooling. We want to save on cabling and space costs. No news to anybody that access layer is changing. First of all, virtualization is causing access layers to grow. We are expanding layer 2 networks. We are seeing multi-chassis ether channel, VPC, Trill, layer 2 multipathing, fabric path. All of them are coming out to address the growing, extending layer 2 networks. When I say unified I/O, I don't mean only FCoE. It is iSCSI, NAS, NFS, all the protocols that can run on the same Ethernet network. Unified wire is a single DCB Ethernet link actively carrying both LAN and SAN storage traffic simultaneously. So, what is unified fabric? Unified fabric is the combination of LAN and storage traffic on a common lossless 10 gigabit Ethernet network. FCoE offers a new choice for consolidated server I/O connectivity in the data center. This will result in a greater quantity of servers having access to Fibre channel SANs than today. While we are on the topic, what is I/O consolidation? I/O consolidation is the capability of a switch or a host adapter to use the same physical infrastructure to carry multiple types of traffic. FCoE complements today's existing connectivity and protocols used in storage and data center networking. The benefits of FCoE are easy to understand. In a typical data center, the backend servers are connected to a separate network infrastructure dedicated to storage traffic. Merging the devices that handle fiber channel and Ethernet traffic provides savings in terms of equipment purchase as well as space, power, and cooling. High availability is a requirement in any data center design, whether it be accomplished through HA at the port level, supervisor level, or even physical network level. Fiber channel FCSONs achieve this high availability by building out two identical but physically separate networks, commonly referred to as SON A and SON B, also called Fabric A, Fabric B. These networks, unlike data center LAN networks, are completely physically isolated from one another and have no knowledge of each other. Depending on host operating systems and drivers, traffic is able to load balance or multipath between the two isolated networks. This isolation is an important element in building FCoE networks alongside the data center Ethernet LANs. With the unified I/O, LAN and SON networks will be sharing the same switches and cabling. The operational costs will be shared between LAN and SON teams. We will be taking the advantage of the Ethernet roadmap, which is 10 gig, 40 gig, 100 gig, while on FC we are still talking about 4 gig, 8 gig, and 16 gigs. So why FCoE? With all the changes within the data center, FCoE helps to facilitate the rolling out of the next generation design and expectations in virtualization, keep current FC investment, provides cost savings for power, cooling, cabling, provides operation savings for automation, management, consolidation. FCoE enables FC to become more accessible. Adapter and storage vendors are building their roadmaps and their strategy, taking FCoE into account now. Now, before moving to FCoE building blocks, let's talk briefly some of the terminologies that we will use a lot. The FCF, the fiber channel forwarder, it's a switch. FCFs are the combination of FCoE termination functions and fiber channel stack on Ethernet switches. Therefore, they are equivalent to fiber channel switches in native fiber channel networks. As of today, Nexus 5K is a FC forwarder, and later on we will have Nexus 7K and MDS. Enodes are the combination of FCoE termination functions and fiber channel stack on the CNAs. And in that sense, they are equivalent to host bus adapters in native fiber channel networks. FCoE pass-through is a DCB device capable of passing FCoE frames to a FC forwarder. FCoE pass-through devices cannot modify the FCoE frames. And the FIP snooping bridge offers the ability to assist FC fabric by helping with the logging process. We have Nexus 4K as a FIP snooping bridge. I also put here let's talk about single hop. Single hop means the server is connected to the access level switch. Multi-hop FCoE is the extension of FCoE beyond the single hop into the aggregation and the core layers of the data center network. How is the addressing in the FCoE world? When a node connects to the fabric, it performs a fabric login, FLogin, and it is assigned a 3-byte FC address or FCID by well-known address FFFFE. This FCID is used for routing frames across the fabric. The entity that receives the address is a virtual endport or Enode, and the address is provided by the virtual F port. The Enode is assigned a fabric-provided MAC address, FPMA, that's built by concatenating a 24-bit FCoE MAC address prefix FC map ranging from 0E-FC00 to 0E-FC-FF to the 24-bit FCID. As you could see in the slide, we have an example. FC map is 0E-FC-XX, and then the FCID is 100001. The FC map range was introduced so that different values can be assigned to different stands. For example, SON A can be associated to 0E-FC00, and SON B can be associated to 0E-FC01. This additional configuration ensures the uniqueness of the produced fabric-provided MAC addresses in the whole network. Here is the display output of the show FCoE from Nexus 5K switch. You can see the FC map on the QLogic Enode. The VM port MAC address is achieved by concatenating the FC map 0E FC00 plus FC ID of virtual FC 201, which is 240100. Today, CNA's Converged Network Adapter present two different types of adapters to host operating systems, Ethernet NICs and Fibre channel HBAs. The operating system, it will appear as two completely separate and physically isolated interfaces. Because of the adapter port virtualization, it's possible to build two separate topologies based on traffic type, one for the Ethernet fabric using the NICs and one for the FC fabric using the HBAs. Then FCoE began shipping. Cisco worked with both QLogic and Emulex in creating the first generation of CNA adapters. These CNAs use a pre-standard implementation of the DCBX protocol, nicknamed SYN-DCBX, Cisco Intel Nuova. These adapters also did not support the standard FIB implementation. Starting in 2009, after the ratification of the FCoE standard, second generation CNAs were put out by both QLogic and Emulex that supported standard FIB and FCoE. These CNAs also use a pre-standard version of the DCBX protocol, nicknamed CEE-DCBX, which is Converged Enhanced Ethernet, Data Center Bridging Exchange. Second generation CNAs are single chip implementation, half height length, consumes half power. In FCoE, an actual fiber channel switch called Fibre channel forwarder, or FCF, exists inside the Ethernet switch. This means that each FCF has its own domain ID, enabling the storage admin to have control of the SAN wherever there's a FC forwarder. The encapsulation and decapsulation of FCoE frames happens in the FCF. FCF uses the same forwarding mechanism as FC, which is FSPF. In this slide, we are trying to simulate the FCoE building blocks, FCoE port types. There are multiple types of ports that are defined by Fibre channel. Since FCoE is based on FC, it also shows the same logic. Except we will put virtual in front of all FCoE port types. The reason why it's called virtual is because the physical port can be used for multiple purposes. A host server target which is connected to the FC forwarder is called virtual M port and is connected to a virtual F port on a switch. Same logic for virtual E ports. They are used to expand the FCoE fabric by connecting multiple Fibre channel over net switches together. VE ports expand the FCoE fabric beyond the first hop access solution. They provide multi-hop FCoE connections between FCoE-capable switches. Do we trunk on VE ports? Yes, we do. We can carry multiple FCoE vSANs. Now let's move on to the data center bridging standards. FCoE is fully defined in the FC Backbone 5 standard, which was developed by Task Group T11 of INSYS. FCBB5 defines mappings for transporting Fibre channel over different network technologies such as FC over TCP/IP, FCIP, FC over Ethernet. All started in June 2007 and finally published in May 2010. FCoE is formed by two standards. One is FCBB5 and the second one is IEEE 822.1 extensions. I want to give you a bit of background for the standards. First, it starts with investigation. People investigate the need for standard technologies to solve a specific problem. Projects usually begin by creating a working group or a task group. Second step is development. Multiple proposals are brought in and discussed, consensus is achieved. When the draft standard is complete and technically stable, it is passed for approval. The third step is the approval phase. Participants vote on whether the standard is ready for publication. And the fourth step is the publication. After approval, standards are passed to mother organizations like publication for ANSI T11 or IEEE for 802.1 extensions. Basically, as of today, for PFC, Priority Flow Control, ETS, Enhanced Transmission Selection, Data Center Bridging Exchange, Congestion Notification, they all passed sponsor ballots. So we are waiting for the publication. Let's talk about some of the highlight standards most important one is the priority flow control. It's important to remember that I/O consolidation requires a single link to carry multiple traffic classes. Link level flow control is required for a lossless traffic. Ethernet and Fibre channel already contain mechanism for link level flow control. Ethernet uses pause feature and Fibre channel uses buffer-to-buffer credits. Each of these techniques stop traffic on the entire link, which limits their usefulness in a unified fabric. Priority flow control is using pause based on class of service as defined in 802.1p standard. When the link is congested, the application that was assigned to a specific class of service to no drop class will be paused. Other traffic assigned to other cost values will continue to transmit and rely on upper layer protocols for read transmission. Not only for FCoE traffic, we can be using it for different traffics, voice over IP as well. We have 8 virtual lanes that can be used, paused. Let's see how it's defined in the NXOS CLI. By default, FCoE is assigned cost value of 3, as you could see, and it is assigned to no drop class. This is a reference slide for you. Here, I want to show you that you can change the cost from 3, which is the default value, to 4, so that the Data Center Bridging Exchange Protocol negotiates PFC for priority 4. IEEE 802.1p defines 3-bit fields that can be used to create up to 8 user priorities within a single physical link. On the right-hand side, you can see the virtual lane bitmap set, so cost 3 is used for FCoE. Another important thing is enhanced transmission selection, which we use for bandwidth management. Bandwidth management is an important requirement when consolidating I/O. IEEE 802.1q-AZ is a proposed standard that defines enhanced transmission selection to manage bandwidth among different traffic classes. When a given load in a traffic class doesn't fully utilize its allocated bandwidth, this standard allows other traffic classes to use the available bandwidth. This helps accommodate the bursted nature of some traffic classes while maintaining bandwidth guarantees. Let's look at the example. You could see that there are 3 classes of traffic being offered to a 10 gig link. The guaranteed bandwidth for HPC traffic is 30%, for storage is 30%, and LAN traffic 40%. At time slot 3, HPC traffic dropped to 2 gigabit per sec, storage remained 3 gigabit, and LAN traffic increased to 5 gigabit. Because one class of traffic, which is HPC, is not using all its reserved bandwidth, another class of service, LAN traffic, can use the available bandwidth. The reserved bandwidth implementation is based on deficit weight round-robin mechanism, and strict priority could also be configured for a class of service. Once FCoE, the feature FCoE is configured, 2 classes are made by default, class default and class FCoE on Nexus 5K platform. By default, each class is given 50% of the available bandwidth, and on Nexus 5500 series, you need to enable QoS and assign a default FCoE policy map that was defined for Nexus 5548. Again, this is a reference slide for you to show how to change the ETS bandwidth percentage on Nexus 5K QoS configuration. In this example, FCoE traffic is given 30% of the 10 gig link. And another important standard, Data Center Bridging Exchange, DCBX. It's a management protocol similar to FLoG and PLoG in Fibre channel, which is a vendor neutral L2 protocol that allows network devices to advertise their capability. DCBX is simply implemented on top of the link layer discovery protocol, which is the IEEE 802.1ab, by using some additional type length values, TLVs. And DCBX provides hop-by-hop support for PFC, priority flow control, bandwidth management, ETS, congestion management, VCN, QCN, applications like FCoE, and logical link down events. Daniel?
Okay, let's move to our second polling question. What are your plans related to adoption of the FCoE technologies? You're currently using them. They are in initial deployment or active planning of deployment, researching or considering, you're aware of the protocol, or you're not aware of the protocol. Please take a moment to answer. Okay, let's have a look at the results. Okay, looks like we have the right people in this webinar today. All right, Osden, back to you.
Thank you, Daniel. So, understanding FCoE. The comparison sounds a bit flippant, but it's actually very accurate. Here's why. On my desk at Cisco, I have a modern Cisco IP phone which works over Cisco's internal Ethernet IP network. At my parents' home, we have a conventional phone, not quite at all. It has buttons, not a dial, but it's connected to a conventional landline. Now, when I call my mom, she can't tell that I'm on a next-generation IP phone, and I can't tell that she's not on one. That's because it's the same conversation traveling over different wires at different places, but with complete seamless interoperability. FC and FCoE are the same way. Now, let's examine how they are designed to work together. FCoE is defined in the same T11 FCBB5 that also defines fiber channels over IP, FCIP. We have a huge ecosystem of many vendors working on FCoE. FCoE uses the same host-to-switch and switch-to-switch behavior. Each FC forwarder allocates FC domain ID. An entire unmodified FC frame is included in a single Ethernet frame. There's no fragmentation. As a result, jumbo frames are required on links supporting FCoE because the FC payload can go up to 2,180 bytes. In terms of protocol mapping, there are two views. From the perspective of Ethernet, FCoE is just another upper layer protocol, such as IP, identified by a specific ether type 8906. From the perspective of Fibre channel, FCoE is just a different way of implementing the lower layers of the FC stack, and it will be running over a new type of cable called Ethernet. FCoE is two different protocols, FCoE and the FCoE Initialization Protocol, FIP. They use different ether types, they have different frame formats. FCoE itself represents the data plane, and the FIP, FCoE Initialization Protocol, represents the control plane. Let me give you an idea right now of what's so-called initial login flow letter, how things will work. Basically, you can imagine to have 4 steps. And the picture here is sort of disproportionate because the real steps that carry all the data and that will carry most of the frame is the last step. When the login has succeeded and you basically start to exchange the FC command, which are basically the read and the write of data, and this is where all the volume of that data happens. But conceptually, to arrive at that 4th step, you need to 3 preliminary steps. In the first step, which is the 5th step, you do a VLAN discovery. You basically discover which VLANs are capable of carrying FCoE traffic. Then on that VLAN, you do FC forwarder discovery. Basically, on that VLAN, you discover if there are any FC forwarders that are capable of speaking FCoE. If the CNA discovers on a particular VLAN where there's an FC forwarder, he may then perform an FLOG of fabric discovery, which is basically the 3rd step. And the FC forwarder will send an FLOG or an fabric discovery accept. At that point, when the first 3 steps are completed, it means all 5 steps are completed. Basically, FCoE takes over and it starts to exchange the data. The first 3 steps may take a microsecond or so, and then the FC command may last for weeks, as we all know. So in terms of percentage of volume, all the volume is in the last step that's done in the FCoE protocol. Let's speak about FCoE addressing and forwarding. FCoE frames basically have 2 addresses, the MAC address and the FC address. And for any Cisco folks that's used with IP network, it's very easy to understand the reason. It's the same reason why an IP frame has an IP address and a MAC address. The IP address in this case is not present. There's an FC address instead. But basically, the FC address as the IP address is an end-to-end address, and the MAC address is a hop-by-hop address. I just basically want to give you an idea that when you are on an FC link, you are point-to-point. So you don't really need the hop-by-hop address, as in the case of a orange frame. When the orange frame gets encapsulated in the blue frame, then you are a true set of addresses. You have a hop-by-hop and the end-to-end. Now, I would like to give you a bit of design steps and design requirements. The goal is to provide any-to-any connectivity. Let's think about for a second the characteristics of Ethernet and Fibre channel. Ethernet is non-deterministic. Flow control is destination-based. It relies on upper layer protocols such as TCP sliding window for drops and retransmitting the packets. FC is deterministic. Flow control is source-based. All the services are fabric integrated. When we are designing our networks, we will need to take into account these two different characteristics of both protocols. When configuring an FCoE fabric, the first step is to create a VLAN to vSAN mapping, which allows the FC traffic in a single vSAN to traverse the Ethernet network. So here we are talking about the single hop design. It's best practice to have dedicated VLANs for FCoE traffic in order to separate the storage traffic from all other native Ethernet VLANs. It's also recommended not to assign vSAN 1 or the configured native VLAN to the FC network. Today, VLAN to vSAN mapping is a one-to-one relationship, and it's not supported to map multiple vSANs to a single VLAN instance. FCoE VLANs are different from typical Ethernet VLANs. In fact, it acts more of a container for the storage traffic than anything else. There's no MAC learning, broadcast, or floating taking place, and it does not map to a subnet. There are two possible single hop solutions when deploying FCoE with the Nexus 5K and Nexus 2K product line. The first is referred to as direct connect, where a host is directly connected to the first hop Nexus 5K, Converged access switch. The second single hop solution deploys FX between the server and the first hop Nexus 5K. You might want to deploy the FCoE with a VPC. And when you are deploying FCoE with VPC, virtual port channel, you need to follow certain rules. This topology only works with generation 2 CNAs. The VFC binds, the virtual Fibre channel interface binds to the port channel. But when I say it binds to the port channel, it binds to a port channel where there's a single port to each Nexus 5K. Now, while the port channel is a VPC port channel, so you are expected to have the same VLANs on the right and on the left. The FCoE VLANs need to be different because you need to implement a dual fabric topology, and the FCoE VLANs are not carried on the peer link, on the peer VPC link. So, just to give you a practical example, if you have fabric A and fabric B, and you have these Nexus 5Ks configured for VPC, VLAN 10 is the IP VLAN, and 20 is fabric A, and 30 is for the fabric B. So, on the leftmost switch, you bind the VFC to a port channel 2, and on the rightmost switch, you also bind it to VFC to a port channel 2. But then, in the trunking configuration on fabric A, you include VLAN 10 and 20, versus on the port channel configuration of Nexus 5K 2, you include VLAN 10 and 30. And although this could be considered as type 2 misconfiguration, it's not, because this VLAN is used for Fibre channel over Ethernet. Now, let's talk about the virtual ePorts and the multi-hop FCoE designs. Multi-hop FCoE is achieved with the support of virtual ePorts, VE-ports, connections to FC forwarders. Like ePorts in native Fibre channel, VE-ports are used to expand the FCoE fabric. Virtual ePorts are supported on the Nexus 5K as of NXOS 5.0.1 and 2 release. There are two options for connecting Nexus 5Ks with the use of VE ports. First one is using single links or over a port channel. Starting with the Nexus NXOS 5.0.1 release, for the Nexus 5K platform, it's possible to tune the port buffer allocation in order to support increased distance between virtual ePorts. Previously, before 5.0.1, we only support 300 meters. Now we can go up to 3 kilometers. Both Nexus 5K and the 5500 platform support virtual ePort connections. VE ports can be configured between two switches using a single port channel or multiple individual links. In topologies that use virtual port channels, VPCs, for Ethernet traffic, separate dedicated links are required to carry FCoE traffic. Ethernet VLANs would be carried on the VPC, and FCoE only VLANs would be carried on the virtual ePorts. VE ports configured between two switches using multiple port channel is not supported. So, I want you to remember that fiber channel over Ethernet FCoE is simply fiber channel. The rules for designing and administrating an FCE network are not fundamentally changed by the latest T11 standard, which is FCBB5. FCoE requires a lossless Ethernet network, and this function is easy to achieve at the edge of the network. But keep in mind that multi-hop FCoE multi-hop FCoE extends the FCoE fabric beyond the access. The move to unified fabric is coming, and cost reductions are in strong demand, and unification is expected to yield cost benefits and management simplification. Cisco is ready and offers end-to-end FCoE solution with Nexus platform. Thank you. Daniel?
Okay, thank you, Ozan.
Thank you.
Let's move to our last polling question here. What is your primary motivation for interest in FCoE? SAN-LAN network convergence, management, operations, cost reduction, benefits related to server virtualization deployments, reduction of data center cabling, simplified server-side networking, or ease of migration from pure fiber channel environment? Please take a moment to answer. Okay, let's have a look at the results. Excellent. Thank you again to Ozan for her excellent presentation. Also, thank you for everyone for participating in the event polling. And now it's time to answer some questions from our viewers today. By the way, if you can't stay with us for the discussion, please be sure to click on the evaluation button to let us know how this session met your business needs and expectations. The first 10 listeners to complete the evaluation will receive a $20 Amazon gift card. And remember, you can keep posting questions at any time. We will be moderating those, and we'll be sending those to Ozan as they do come in. Okay, let's move on to our first question. Does NXOS 5.0 run NP-IV?
Yes, thank you for the question, Daniel. Yes, NXOS 5.0.1.5.0.2, yes, it runs, it supports endport ID virtualization, and it also supports NPV. Nexus 5K release, Nexus 5K supports two terms. First is the switch mode, and the second one is the NPV mode. On top of that, Nexus 5K with the NXOS 5.0 release, it supports NP-IV.
Okay, great. We have another question here. Is FCoE between data centers possible?
Thank you for the question. Yes, FCoE between data centers, it is possible. As I mentioned in one of my slides that while I was talking about multi-hop FCoE, we extended on the Nexus 5K platform the QoS buffers so that we can extend the multi-hop FCoE for 3 kilometers.
Okay, we have another question here. Can you explain the VLAN trunking channels a little bit more?
Thank you for the question. So VLAN trunking, actually these are all probably our attendees based on storage background. So VLAN are, we support virtual LANs on top of the fiber channel over Ethernet networks. So trunking means we carry different virtual LANs all together in one ISL. And the same on the FCoE, we also support the virtual SANs, and we can carry multiple virtual SANs on one ISL. In terms of multiple FCoE, we will see that we could carry multiple virtual LANs and virtual SANs together.
Okay, let's go to our next question. Can FCoE be used with the UCS?
Thank you for the question. Yes, now, UCS, when we talk about UCS, we have the latest version, which is the 1.4 Balboa release. You can connect FCoE target to Fabric Interconnect. And we are already running FCoE in terms of Fabric Interconnect connecting to the FEGs and then the blades. But if you would like to extend, like, can I do multi-hop between the Fabric Interconnect and the Nexus 5K, at this moment we can't do that. But you can connect the fiber channel and FCoE targets directly to the Fabric Interconnects.
Okay, we have another question. What is the next data rate after 10G for fiber channel? Is it 16 gig? When will it be supported?
Thank you for the question. After 10 gig, the discussions are 12 gig and 16 gig. Probably we are ready for the 16 gig. And if in terms of you're asking us or other vendors will be supporting 16 gig, yes, it's in the roadmap.
Okay, we have another question. Is there a limit on the number of hops that can be made in a multi-hop environment or design?
And the thing is, there is no, the limit is 7, actually. You can have up to 7 FCoE hops that's tested and supported by Cisco. So we can, but if there are requirements to go more than 7, that can be tested in Cisco labs as well.
Okay, we have another question here. Can we configure multiple COS values for PFC?
Yes, we can configure multiple values for the PFC, and this can be like, we have, as I mentioned during the presentation, we have 8 lanes, and lane 6 and 7 are reserved for the control, and the rest of the lanes can be used for the PFC, setting the different PFC, changing the FCoE using PFC 3, COS 3 to a different PFC.
Okay. Next question. What if we want to trunk multiple data VLANs to the servers running ESXi, for example? Do we still need to configure trunking on the switch ports?
Thank you for the question. Yes, if you trunk multiple data VLANs on the servers like the ESXi as typical, we definitely need to configure the trunking. And when you configure the FCoE on a switch, it's valid for the multi-hop or single-hop, multi-hop FCoE designs. always the port is set to transport so that we can allow to carry multiple VLANs, vSANs together.
Okay, next question. What is the difference between CEE and DCE?
CEE is the Converged Enhanced Ethernet, and I mentioned this during my presentation. The CEE authors group was an informal group for group of companies that submitted the initial proposals of PFC, ETS, and DCBX to the IEEE DCB working group. And DCE, Data Center Ethernet, is a Cisco term that describes an architectural collection of Ethernet extensions based on open standards. DCE includes support for the Ethernet extensions found in IEEE DCB.
Okay, next question. How is the FCoE license activated on the Nexus 5000 or 5500 series?
When ordered as an option to the Nexus 5K storage service license, the code is activated when shipped from Cisco. When ordered as a separate line item, an activation key and the procedure for activating the code is delivered in an envelope. The code is always present and only activation is needed. And any M5K will automatically initiate a 120-day temporary license for the storage protocol services code upon first use of an FC or FCoE command.
Okay, thank you. I'd also just like to remind everyone you can still submit questions at any time. We do have some time left to answer your questions, so please don't be shy and do submit your questions now. And now we'll move on to the next question. Is FCoE IP routable?
Thank you, Daniel. No, there is no IP layer in FCoE. FCBB5 contains FCIP, that's IP routable, but FCoE is FC routable. FCoE switches may forward FC frames across different Ethernet clouds. FCoE switches may forward FC frames over the Internet using FCIP.
Okay, let's go to our next question. Do I need to enable jumbo frames for FCoE?
Yes, during the presentation I mentioned that you need to enable the jumbo frames for FCoE because when FC frames are encapsulated in FCoE frames are encapsulated in Ethernet, the frame size may go up to 2180, and with the QoS settings, you need to by default it will be set 2158, and you also need to enable jumbo frames.
Great. Let's move on to our next question. Can you advise on any resources for FCoE so I can read more about them?
Excellent question, actually. We have some slides that I provide some recommendations for some articles and books. And one of thank you, Daniel. So the book, which is from Silvana Gai and Claudio De Santi about the I/O consolidation in the data center, it's really, if you need to read one book about FCoE, this is the book. And they also made before this book, I/O consolidation in data center, they also published the data center networks and Fibre channel over Ethernet FCoE. But this was long before the standards, so you can read these two books.
Okay, thank you. Next question. Can I use multiple classes of service for FCoE?
Yes, you can use multiple classes of service for FCoE. I mean, you can use, as I mentioned, you can use 3, 4 classes for the FCoE. And the important thing is we have 8 lanes and 8 QoS groups. QoS 6 and 7 are reserved for controlled plane traffic. So given the fact that 2 of these 8 QoS groups are taken by the system, it leaves us 6 QoS groups to use. One of these 6 QoS groups is predefined as a drop class, and it's class default, no drop class, and that leaves us 5 QoS groups. Of these 5 QoS groups, only 4 can be configured as no drop, and one of these could be FCoE.
Okay, great. Let's move on to our next question. Did Cisco produce interoperability testing results with various vendors?
Thank you for the question. Yes, we have the interoperability matrix that we published on CCO on Cisco.com, and we have different results with the storage area OSM vendors and the CNA adapters. You can see which NXS code, which CNA firmware software version, and which OSM partner, OSM target is supported. This is all published in the interoperability guide on CCO. Also, some of the OSM vendors also, publish these interoperability tests on their sites.
Okay, let's take another question here. Can the concept or purpose of worldwide names be briefly explained?
Yeah, sure. So the worldwide names are the ones in the Fibre channel world, when a device logs in, it asks for the Fabric login and it gets an FCID from a well-known address, FFFFE. And the thing about the worldwide names are like the MAC addresses of the host-bus adapters, and so that they are unique and assigned. So for Ethernet background people, worldwide node names, the worldwide port names are the MAC address of the host-bus adapters. And same, it exists when it's connected to a Fibre channel switch. In each switch port, we have the worldwide port name that's representing the port. It's a 64 8-byte address, and when you do the show of FLOG, you could see the device port number and the world port byte name.
Okay, let's go to another question here. Which CNA types are supported on Nexus 5000 and Nexus 2232 PP?
Thank you for the question. So for the Nexus 5K, we have two flavors as of today: Nexus 501020, Nexus 5548, and Nexus 5596. For the Nexus 5548, we support Nexus 2232. We support the Generation 2 CNAs, like from the Emilex and the QLogic. If I need to give the names, QLA 81 4X or QLA 8150, or QLogic or Emilex 1 Connect, which is a Generation 2 CNAs. And for the Nexus 501020, we support the prefix CNAs, which are Generation 1 CNAs, like Emilex LP21, QLogic 800 4X.
Okay, thank you. We have another question come in. We do have a few minutes left, so please do post your questions if you have any in our remaining 5 minutes. Next question here. Is there any training or course certification leading to FCoE knowledge?
Okay, thank you for the question. There are some data center certifications in Cisco terms. We have the qualifications, and as far as I know, we will have the latest, greatest CCIEs. For sure, we will be certifying for the FCoE certification. But as of now, we don't have any certification outside of Cisco or any other vendor. But I believe it will come very soon.
Excellent. Thanks, Ozden. And that will conclude the Q&A portion of today's event. If you do have additional questions, please do log on to the Cisco Support Community URL shown here. Ozden will continue answering your questions via the community site over the next 2 weeks. If you have not explored the Cisco support community, please do take a moment to check out this excellent resource. Also, I'd like to invite you to attend Cisco Live Melbourne 2011. That'll be taking place on March 30th. You can absolutely attend virtually if you can't make it in person. You can participate right here at CiscoLiveVirtual.com. The one-day hybrid event will feature keynotes, technical sessions, and live executive chats. Also want to let you know about a great new iPhone app that was just released from the Cisco support community. You can download this right now via the App Store for any iOS devices, and you can participate in all the forums and chats inside the Cisco support community. Please do take a moment to download that if you have an iOS device. Please do make sure you complete your evaluation today as well. This will help us address your business needs in the future. Thanks again to our expert, Ozin, for sharing her expertise with us today.
Thank you, Daniel.
Thank you, everyone, for participating. And we wish you a great afternoon.